We will cover SIP trunk sizing in this section, meaning we will talk about all the performance numbers that we have gathered for Cube with respect to various different call flows. A quick note when it comes to sizing Cube Enterprise on-prem deployments or even cloud-based deployment, the sizing information presented in this deck is a guideline. Actual session count always varies based on the number of features you turn on the underlying ISR, ASR, or CSR 1000V platform and depends on the iOS XE version being used. Okay, so I will begin with covering the testing methodology. When it comes to testing, let's get some terminology over here with respect to what are different call flows. Collab calls, or also referred to as basic IP telephony calls, are when IP phone registered to, for example, UC Manager, make an outbound PSTN call, and that call goes from UC Manager to Cube via SIP trunk and then Cube to a service provider. So that would be a basic IP telephony call. Contact center call generally is referred to as inbound Cisco UCCE or outbound Cisco UCC calls going through Cube. For the most part, it's considered from a sizing perspective, it's an inbound PSTN call on Cube, ingress Cube, otherwise we like to refer to as ingress Cube for CVP treatment. The platforms that we test are basically presented for we have tested all the Cube platforms, all the current Cube platforms for determining their sizing and metrics, and those are the numbers we will be sharing you in subsequent slides. But keep in mind when we test uh, the Cube call flows on these platforms, we present the box with a constant call presentation rate. The presented CPS value, uh, that's the one we document on the data sheet and in this deck. And we only do one type of a call flow. So if you're doing collab calls, we are doing all collab calls in the testing. If you're doing UCC calls, we're doing all UCC calls. And we set the call hold time to 180 seconds. So the CPS that we publish in this deck and the one in the datasheet is the maximum sustainable average presentation rate. Higher instantaneous CPS rates are possible, but that is something we no longer test. The testing focuses on a few things. Number one, the number of successful simultaneous or concurrent calls, and we benchmark them at around 70% CPU and memory utilization. This sort of buffer we do so that if you want to turn on other features on the platform that might require resources from the CPU and memory when it comes to iOS XE processing. So again, we benchmark successful simultaneous calls at 70% CPU and memory utilization. We configure static IP routing on all the platforms to deliver the packets to the next hop. We don't generally test with various different combinations of IP routing protocols. Okay, so some general guidelines when it comes to cube sizing. All the deployments must be done with the following memory combinations. On the ASR 1000 series platforms, all cube deployments must have 16 gigabytes of memory. For the ISR 4400 series, it should be 8 gigabytes of control plane memory and 2 gigabytes of data plane memory. On the 4300 series, we test with 4 gigabytes, and for the ISR G2 series, we used to test with 2 gigabytes, meaning all your cube deployments must have at the very minimum or at the very minimum the memories that are listed over here for the platform type. The session count, from our perspective, the numbers we publish are end-to-end calls and not call legs. So a single audio call will have two call legs. So when we say a box can do 100 sessions, that means it can handle 100 calls, meaning 200 call legs. And it's dependent on the amount of memory in the box, and it's done based on the memory that we have listed in the first bullet. Cube Media Proxy cannot be co-located with Cube Enterprise. Cube HA generally has no impact, but under a full load, we recommend taking out 5% overhead just for a complete when a box is being bombarded with maximum number of calls that it can handle based on the numbers we have published. So we recommend at that point to buffer about 5% when you're doing Cube HA. Q plus iOS XC based software MTP colocation, generally if the numbers are available, uh, go ahead use them. In case for a certain platform Q plus iOS XC based software MTP colocation numbers are not available, at which point what you can do is you can equate one software MTP session on the box equivalent to one Cube IP telephony session, or which is the Cube collab calls. Um, and at that point, you should not exceed the total number of cube collab call numbers, meaning the session count that we list in the data sheet or the basic IP telephony numbers should not be exceeded. So for example, if you have a box that can handle 500 cube calls and you want to, and the numbers for iOS XE based software MTP co-located with cube are not available, then you should target no more than 250 cube calls on the box, and another 250 is you, in your calculation reserve for software MTP, not to exceed the total 500 capacity. Complex call flows, Cisco UCCs is what we like to refer to as complex call flows, can reduce both the CPS and session count. Previously, we used to say 75% drop in your calculation. That is no longer the case with iOS XE 16.12. There has been significant performance gain for not just basic collab calls, but for UCC call flows as well. And we will share those numbers with you in the coming slides. Okay, we will also show a number with various different SRTP over with SIP TLS, basically various different crypto and codecs use when it comes to SRTP. The SRTP numbers will be for SRTP RTP or SRTP crypto A to SRTP crypto B, meaning you will have to uh, get the SRTP packet, decrypt it, and encrypt it again with a different crypto and send it out. Or it can be SRTP to SRTP using the same crypto, but still in that call flow cube gets the packet, it decrypts it and re-encrypts it. There is an option to do SRTP pass-through, and what SRTP pass-through, when you configure it, cube just passes across the SRTP packets without examining the contents of the packet, without decrypting it and re-encrypting it. And when you configure that, the session count and the calls per second can be considered same as the RTP to RTP call numbers that we will be showing in the tables. Okay. Header manipulation or SDP manipulation generally does not have any impact, but again, under full load, you can, for SIP header manipulation, you can reserve 5%, and SDP truly depends on the kind of SIP profile you have. But for example, if you want to change the codec orders in the SDP from the incoming to the outgoing, so that is something that takes about 6% hit. Media forking for call recording can have a 50% impact on the IP telephony session count numbers, meaning the basic collab call numbers. And it just depends, and regardless of the type of call, if you are recording a basic IP telephony call or a complex UCC call, the call leg from the cube to the recording server should be counted as a basic collab call. This includes SIPREC, Cube with the open recording architecture, which was with Cisco MediaSense, and the CUCM network-based recording. We'll try to publish numbers for long-lived releases, which means the numbers in this deck are applicable to the latest 16.9, 16.12, and 17.3 iOS XE releases. Okay. So again, as we mentioned, with call processing capacity for any Cube instance is influenced by several different considerations, including the iOS XE release, the features you have configured on the platform. Our general guidance is that take advantage of the call admission control feature on the Cube, whereby we recommend that you configure CAC for CPU utilization and total memory at around 80% resource threshold. What this means is that when you have this configured, at any given time, if the CPU utilization hits 80% or the memory utilization hits 80%, you will stop processing newer calls till such time that those resource thresholds come down to the low threshold mark, which in this CLI that we are showing over here is 75. If you want to take a look at the active number of total calls that are present on the box, you can use the show call active total calls CLI to get the concurrent number of calls that are happening on the box at any given instant. Okay. Let's move on to collab calls. These are basic IP telephony audio calls. So let's take a look at the numbers. So a few things. Again, we are only going over the current Cube platforms, which are the ISR 1100 series, the 43, 4400 series, the CSR 1000V series, which is with 1, 2, and 4 vCPU, along with the memory option for the CSR 1000V, 4GB, 4GB, and 8GB, and then the ASR 1001X, 2X, 1006X with RP3, and 1004, 6, and 6X with RP2 and ESP40. So with CSR 1000V, which is the virtual cube, we have listed the underlying host we utilized along with the CPU, the processor specs that it was running on ESXi 6.0. Refer to the CSR 1000V documentation on what the CSR 1000V requires as an underlying virtual router, and Cube supports whatever the CSR 1000V supports from specs perspective. From deployment perspective, there are some caveats. We'll cover that in the vCube section. So for all these platforms, these were the numbers that we used to publish for iOS XE releases 16.6 or earlier. Starting iOS XE 16.12 or later, you can see for a lot of the platforms, the numbers have changed significantly. Again, remember in this slide deck, what we are showing is basic IP telephony audio calls, right? Which we also like to call as basic collab calls. The incoming call leg is RTP, the outgoing call leg is RTP, and both legs are using G711 as the codec. So ISR 4321, we used to advertise no more than 100 sessions. From this iOS XE release, it can do 500 sessions. And then the 4461, our newest box in the ISR 4K series, supports up to 10,000 calls and requires iOS XE 17 to 1 hour or later. For these calls, what was the presented call presentation rate, which is the sustainable CPS? We have also documented those. Then let's move on to encrypted collab audio calls, meaning SRTP to RTP and SRTP to SRTP. So again, as a reference, what we have listed in the first column is all these platforms, and what we are showing over here are the standard basic collab call numbers, and then if and then you turn on encryption with SRTP to RTP. So what this table is over here showing you is that if the inbound call leg is SRTP with G711 and the outbound is RTP in G711 and vice versa. So with SRTP 711 to RTP 711, these are the total number of sessions you can expect on the box. And what we are showing is the impact of those as turning on encryption with respect to basic collab calls. So for example, with the 4331, it can do 1000 unencrypted basic collab calls. If you turn on encryption on one leg on one leg of the call, then you have a 40% impact to those basic collab numbers, and it drops down to 600. One point to note, and then we also have mentioned the calls per second for those encrypted calls. One point that I would like to bring your attention to is the impact of encryption on 4461. 4461 is the platform that has hardware encryption built into it. In fact, the only one within our portfolio that utilizes an hardware encryption chip. And you can see because of that, the impact of turning on encryption is almost negligible. So this platform supports 10,000 basic collab unencrypted collab calls. You turn on encryption with SHA-180, it can do about 9,900 calls. So you can see almost no drop and no drop to CPS as well. Okay, and then this table basically again the impact of turning on encryption with GCM 128 on the SRTP, and then the next one is with GCM 256. And then this table, if you have SRTP on both the legs, with same audio codec 711, but one leg is SHA-180 and the other one is GCM 128. And for your reference, again, we have the basic collab numbers unencrypted on the left. And then this one is SHA-180 to GCM 256 on Cube. So you have those numbers for audio calls. We have also published numbers for encrypted video calls. And again, generally with video, service providers don't support video over SIP trunks. So those video calls are going over the top. So it makes sense to have at least encrypted. It only made sense to do encrypted video call testing since any video calls goes over the top. So you have to encrypt it with SRTP. So we have published encrypted video call numbers on Cube for various different platforms. The first one with SHA-180, this column with GCM 128, GCM 256, SHA-180 to GCM 128, and then finally SHA-180 to GCM 256. So these are basically, if you have video calls running on Cube with this memory type, how many encrypted SRTP to SRTP video calls you can expect with SHA-180 to GCM 256, along with the CPS. Then coming to the contact center call flows, those are the complex call flows. Again, if you remember, these are the first column is your basic collab calls, and then this is the UCM capacity, UCC capacity that we use to advertise. For example, with ASR 1006, it used to be 16,000 calls, and we used to say 75% blanket drop to 4,000. Now we have tested each and every platform, and in some platforms you can see the impact is virtually nothing. So for example, a 4321 can do 500 collab calls. If you were to present it with 500 UCC calls, it can handle it without any issues with the same resource utilization. And then we have also published calls per second numbers. So you can see pretty much across the board with all the platforms, the number of UCC calls that a box can handle has gone up significantly. And we have again listed the impact of UCC to IP telephony calls. So for example, in case of CSR 1000V with 4V CPU, which can do 6,000 calls from iOS XE 1612. If you want to use this as an ingress cube for UCC call flow, it will be able to handle 40 to 50 call, meaning it only has a 29% impact when compared to IP telephony numbers, and the calls per second will be around 24. Let's take a look at a sample sizing. As you can see that the impact to various call flows when it comes to encryption or UCCE, the impact is no longer uniform, which makes sizing a little bit tricky. So you can see with different platforms have different impacts. So what we'll do is like how to select a platform based on these new numbers. So we'll do a quick hypothetical case study. So let's say an enterprise is considering a 4451X for their collab deployment, and they have the following requirements. They want to do 500 unencrypted basic collab calls. Then they want to do 100 Cisco UCC calls, and they want to record all the UCC calls, which means those recorded legs are another 100 IP telephony calls the platform has to handle. They want to do 50 SRTP to RTP audio calls with SHA-180 on the same box. And then they also want to do 100 SRTP to SRTP audio calls on top of all the load that we have listed over here from top to bottom. So what we have to do is we need to see, can the 4451X meet the customer's requirement? So with the 4451, without going back to the slides, you can see I have put all the numbers over here. It can support again 6,000 IP telephony calls. So what we have done is we have taken the requirements over here and we have seen the ratio to IP telephony calls, right? So for example, in the case of UCCE, if you go back and see, it has a 40% impact. So what that means is numerically every UCCE call that the 4451 X handles, that UCC call is equivalent of 1.67 IP telephony call, right? For the recorded call legs, we said that the recorded leg should be treated as an IP telephony call. So that impact is 1.0. With SRTP to RTP, there is a 65% impact. So every SRTP to RTP call that the 4451X handles is equivalent of 2.86 basic collab calls. And for the SRTP to RTP, one SRTP to SRTP call is equivalent of 11.11 uh, uh, basic collab IP telephony call. So what we're going to do is we're going to multiply these requirements, these numbers with these ratios over here to convert everything to the IP telephony scale. So 500 unencrypted IP telephony calls multiplied by 1 because that's the basic collab load. Then 100 contact center calls multiplied by 1.67, 167. We are recording all contact center calls, that's 100 IP telephony calls. 50 SRTP, RTP audio calls with SHA-180 times 2.86, that's equivalent of 143 IP telephony calls, and 100 SRTP to SRTP audio calls, you multiply that by a factor of 11.11, that's equivalent of 1111 IP telephony call. You add these numbers, that means it's a total capacity in terms of IP telephony scale numbers around 2021, which means the 4451X can comfortably handle the customer load because it has up to 600 IP telephony call capacity. When it comes to licensing, what kind of cube licensing would be required over here? You will require for 500 unencrypted IP telephony calls, will require 500 trunk license. Then the additional 100 contact center calls will require another 100 call license. The 50 SRTP to RTP is 50, and then the 100 for the SRTP to SRTP calls. The the call recording element, right, does not require any additional licensing on the trunk side, and we will cover that in detail in cube licensing. So you add them up together, the customer requires a total of 750 cube trunking license over here. So that covers our iOS XE sizing with respect to Cube Enterprise platform.